transport. From here, it is computer host. Session. Presentation. Application. So physically is your hardware, and MAC is how you control your hardware, and routing is how you hop to the next computer. So from now, we're going to talk about your host. Then I may have a multiple application in the same computer, like you are enabling YouTube and Facebook, Instagram in the same smartphone. Okay. So let's look at the internet architecture. We talked about this until this point. Okay. So let me quickly review. So this is basic internet architecture if we compare it to the OSI 7 layer. So we talked about on top of the IP, we're gonna talk about TCP and UDP, which is in the view of the OSI 7 layer, which is transport layer. Okay, IP is best effort. UDP and TCP guarantees is delivery. So from here is host view. Okay. Till here is more like network. Okay. So we know what the acronym means. And end to end. So transport layer, if you talk about TCP, if you talk about UDP, is end to end. What does the end to end mean? Okay, so from my computer, let's say I'm watching YouTube, and the server in YouTube server, YouTube Korea, let's say they have a BTS music video. So in the middle, there may be some routers. Some routers, something like SUNY K router, KT in Yonsei, KT in Incheon, and maybe KT in Seoul. They are connected by. Okay, so hop to hop, hop to hop. That is network layer. So I do care about my service from the YouTube. I don't really care in the middle. But what I want to know, I want to enjoy my BTS music video in 4K in live. That's what I want to know. That's the quality that I need. So transport layer cares end to end. They don't care in the middle. So end to end meaning, if I'm fetching too much, I should ask less, right? And if I'm expecting the buffering, let's look at the other view. Let's say I'm a YouTube server and you're a client. Then I'm providing contents to your computer. If your receiving buffer, your computer can digest how much that I'm sending, even I'm sending huge chunk, if your computer is fast enough and can handle the high data rate, then they're called your receiving and my end, that is called flow control. Okay. Oh, if your receiver does not digest, what do? I'm sending less. Then receiver buffer may handle traffic and have more opportunity to digest. Okay. So in the network, in the view of network, if I'm sending huge file, in the middle of network, they cannot digest properly because there are so many clients who want to watch the BTS live music video. In the view of the network, we called congestion control. Okay. So TCP and UDP responsible for realization to host packet delivery. Okay. It guaranteed message delivery end to end. If it is missed, you may ask again, or you may skip to the next. If it is the live video, so you asking again doesn't meaning nothing, right? Because I want to watch live. I don't want to watch the 10 minutes ago. That's meaningless. Okay, based on your application, they determine asking retransmission or no. And order delivery, meaning I want to consecutively watch the music video, not then in the tail, then I'm watching the head again. So what I declare is a play. Okay, therefore I may reject the duplicate messages for the same file. And message of the arbitrary length, the video chunk size, they handle this. And congestion control, oh, we know what's the congestion control. Congestion control is related to network overloading. We also talked about the flow control. Flow control is end-to-end, meaning sender to receiver. So it can running multiple application process at the same host. Like I'm watching YouTube, the MLB live. At the same time, I'm watching the BTS live. Okay, so why do you need to know about the transport layer? Transport layer can drop the message, can reorder the message, and deliver duplicate copies of the same message, limit the message to finite size, and all these things are done on the transport. So remember, this is end-to-end. And on this class, we're going to talk about UDP and TCP. So the biggest difference between TCP and UDP, TCP is somehow collect the feedback and provide the best environment, best services that they can do. But UDP is less responsible, but they do what they can do best. Okay, then we called UDP is best effort IP end-to-end service. TCP consists of the connection setup, discarding corrupted packets, retransmission of the lost packet, and does a flow control, does a congestion control. All these things is done in the TCP. And there's a RPC, remote procedure call, and request and reply service. So this is commonly done, request and reply, in server messaging. Server messaging meaning if you're running a server responsible for something, if the new query is coming, then you may respond it. If you request something, you may respond properly. So this server, like a Spectrum DB, and most of the DB works in request and reply. So this was also the lab too. Okay, so we will gonna focus on these two, and we're gonna talk about two. So we talked about flow control and congestion control. It looks same. So what's the difference? So when you're talking about end-to-end sender to receiver, that is a flow control. So when you're talking about traffic into the network, then it's congestion control. And I think we read this in the last class, and maybe I can skip. So today, David says, if the UDP is less responsible, why is it choosing over the TCP? Is it faster? So UDP. So David is asking, is UDP is less responsible? Why do we choose over the TCP? Okay, about 5 years ago, TCP is the king. We didn't use the UDP, but theoretically, TCP is much complex than UDP, right? Then they do something. They can control something, right? That is true. If the UDP is less responsive, it is true. But if we have alternative way to make it be the responsibility, so I make the UDP as light as possible, and I control in a different layer. That is QUIC. QUIC is Google's UDP-based transport layer. They handshake beforehand, like your Chrome is periodically update the encryption keys, then they know what keys need to be done. But if you think about the TCP, you have to exchange the key, then you are confirmed, okay, you are the authorized, then I can keep sending it, okay? Then you make the transport layer lightest as possible and deliver. But you don't need to worry in the middle, but you could be more greedy and you can deliver more. But it is working because if you think about the network traffic in today's today's world, where do you use YouTube, Instagram, Facebook? But you are watching YouTube a video, right? So most of the traffic is done by video, and it is the operated by the one company, and you are using Chrome. They know your encryption key, and they can deliver much faster because they don't need to exchange again. Okay. If the security, if the other things are handled already or different entity, then you don't need to worry. Then you can use the lightest one. That is a QUIC. The QUIC is acronym for QUIC. So we're going to talk about it later, later section. So I think UDP is a passive. UDP means passive. So I think Janara tried to say it's a passive, meaning TCP is a handshake and set up the connection. Then they do. The UDP doesn't need to. They don't need it. They just send it and forget it. They send it and forget it. Therefore, there is someone else who can take charge of it. Who can take charge, meaning someone who can take care of the responsibility, someone who can take care about the authority and security. Then they do more passive. I think Janar tried to say it in that way. Okay, is there any other company that uses UDP than Google and related company? Oh, so anyone can use a UDP or TCP. So UDPs and TCP concept is about your navigator. Navigator meaning if you are Internet Explorer, you may use the Firefox, you may use a Chrome, you may use the Internet Edge. That level. Many servers, I think most of the servers support both of them, UDP and TCP. Okay, both of them. Most of the computers, most of the servers support UDP and TCP. So we know that the TCP is a market winner for 20 years. Then we know that UDP is much simpler. It should work better, but it doesn't take responsible, so it is not chosen by the industry. Then the dinosaur comes to the market, which is Google. Okay, you know what? I know UDP is much simpler and faster, but in reality, it is much slower. I'm going to solve this by using a QUIC. It is possible because all users already have a Google platform, which is Chrome. Then you are using Google's contents, which is the YouTube. Then you start to killing all the competitors. Now, so if you think about your network traffic, in my view, I'm like 90% of YouTube. If you compare it to the compare it to the network traffic, then the usual people will be like me. So using much simpler, responsibility is different entity, then they do handle by the browser, then it is much faster. So Apple using it, everybody using it, but in the view of the performance, UDP lost for a long time. Then Google coming and they start to install the Chrome all over the places and they start to work. Is the UDP cheaper than TCP? What do you mean cheaper? In the cost of the cost? Everything is free. UDP and TCP is just protocol. Okay, thank you. Thank you guys. Thank you for the great comment. 19. David. Okay, go back to the point. So let's look at how the UDP look like. It is very simple. If I'm sharing with the TCP, remember this, very simple. And if I'm sharing with the TCP, it's much complex, right? For the same message, TCP has to have how they control the traffic, how they control the network traffic, and how can you control the ordering. All these things that need to be done inside of TCP packet. Therefore, it's much complex. Go back to the UDP. It's much simpler. So they do nothing but source port and destination port and length and the checksum. That's it. Then your data. Okay. So source IP and destination IP is handled in a lower layer, and they do care about the port in the transport layer. So processes are identified based on incoming port socket. In Windows, you did it, right? And 16-bit for each field yield 64K different identifier. And IP and port combination allow demux at the receiver. Do you understand mux and demux? I think I learned it in the very basic course of the physics, mux and demux. No? You never heard about the mux and demux? Okay, don't worry, I'm going to cover in detail. So, mux is something like this. If I have a multiple thing, then my output is only one. Then I have to add identifier, then it should follow everything in the same path. Demux is, if there's something very similar is coming in, then it should have identifier, which is belong to me, which is belong to me, and which is belong to me, which is belong to this guy. Okay, mux, by the control flag, multiple things are coming in, I'm sharing one path. This is very common in circuit. And if the one thing is coming, I should divide to correct destination. This is demux. Okay, go back to the point. So IP versus transport. So IP is a lower layer. I have internet connection. IP is host to host. UDP is process to process. I may open the multiple YouTube streaming. I can open the YouTube streaming on the BTS live streaming, and some of you may open the Zoom. Some of you may open the MLB Live and the Champion Series. Then every process needs to be muxed to the IP, because IP is one per computer, but I could have a multiple port. Therefore I can running multiple processes. Okay. So encapsulation and decapsulation, we understand what it is. So I have a messages, oh, hello world, and the message become UDP packet, an IP packet, and actual frame that is delivered over the internet and reversed way and decapsulated. So this is known port 53 is DNS, port 22 is SSH, something like this, and port 80 is HTTP, HTTPS is 8080, and email uses 25. So every process has their own port. So how do we know we are using same port? Then we are following IANA. IANA is International Authority of Network Assignment. IANA, what's the IANA? Internet Assigned Number Authority. Internet Assigned Number Authority. That's the port mapper service. So if you look at here, okay, here is the IANA. From port number 02 all the way, it is already mapped. Okay, so if you want to, so in my age, it was very popular to make a proxy server. Okay, so if you want to use, if you have your own proxy server, it is not able to use the already established port. Do you understand what is a proxy server? Just quick talk. What's the proxy server?
It's something like a, I mean, in easy terms, it's a VPN.
So about 15 years, maybe 20 years back, proxy server is my life at that time. Why? I served in the Army, and most of the traffic is blocked, meaning I cannot, at that time, we don't have YouTube, but let's say it is YouTube. Let's say it was Instagram. Let's say it was Facebook. It was Facebook is like a side word long time ago. And YouTube streaming service, video streaming. We didn't have a streaming service. We used to have the audio streaming. Instagram, maybe cyberspace, something like this. So let's say you're sitting on the computer in the Army network. Everything goes to these services. It's not related to the national security. Therefore, they blocked it. Oh, but you are like, you're staying in the chair for a while and you want an internet connection. How they solve this? We set the our proxy server inside of my house. What can I say that my house? We call the bunker, but I don't recall exact name. So somewhere I stay, okay. Somewhere I stay, I sleep in here. I have a computer. Then I set the one proxy server, which means from the Army network, it looked like internal computer. So it is important to connect it. So my internal computer is connected to Facebook because I have outer KT line. Then Facebook comes in and goes to the Army, Instagram comes in, and YouTube comes in the Army. And many of the my friends are all sharing with this connection. Then they can enjoy the Instagram and Facebook, whatever they do. No, not the Sachibang, no, my room. Like I had a room with my roommate, and I had one computer. So what is this happening about China? Do we have a Chinese student? No, I don't think so. So let's say China. Just for your information, China blocks the YouTube, China blocks Facebook, China blocks the Instagram. But people in the China, let's don't do the China then. Let's say, forget about China. Let's say it was North Korea. Okay, I'm sure the one guy, they call the Kim Il-sung University. Let's call the top university in North Korea, computer scientist, CS student. I'm sure they are accessing Facebook. I'm sure they are playing a stream. I'm sure they are watching YouTube. Okay, then how they connect it? So network is not allow you to go to outside. Then they should have a proxy. Proxy meaning from the internal network, it looked like internal, but external network, it should look like the normal computer. Then they may have one proxy in their dome and one proxy in outside in China, in South Korea. Then they look like the connection in between, and they are connecting, and they are using all these things. So I used to set up my proxy server in my computer, and we used to set up the replay on the audio streaming. We used to do that. If I spend more time on it, and if I spend most of my energy on it, so maybe I'm being more successful guy than now. Okay, so internet, whatever. Okay, so back to the point. So whenever you do port mapping, so your port should be disguise your identity, and to do that you have to follow the IANA's the authority, and most of the known and short port is already assigned to the others. Okay, so MUX and DMUX. We talked about MUX and DMUX. Okay, so host may be running multiple processes at the same time. So like I'm watching YouTube and like I'm watching MLB Live. Then process generate multiple messages for the same host and generate multiple messages for multiple hosts. Then in the middle, multiple generated and should share the one. Then we call this process called the MUX, multiplexing. So transport layer MUX is MUX messages from multiple processes. Break down the message to segment and pass to the network. So transport layer DMUX is doing a reverse way. So this is look like this. So I have YouTube, I have Facebook, I have YouTube 2, then maybe MLB Live, and I have Zoom. So I'm using one computer, one IP, 192.168.2.15. Okay, so even I'm using one, then how the packet, when the packet is returned, how do they know it is me? And I'm sharing one medium, then how they overlap each other. Okay, then that process we call the MUX, multiplexing. So wherever the messages are created, I make it to the standardized IP packets, that I make it to the smaller segment, then just deliver to the network. Then whenever it replied, oh, port 52, port 50 should go to this way, port 53 should go this way, port 8080, port 8080. Even the port are same, they should have different flag. Something, oh, this message is YouTube, this message is for Facebook, this message for MLB. What if I'm watching the multiple YouTube at the same time? Okay, even you are watching multiple YouTube, you should have a different different process. So in the Ubuntu TP, it shows the top TOP command. That command shows you the running process, like you are task manager, show you the process ID. Okay. So UDP Message Queue. So application processes for something like YouTube, something like Facebook. Let's say make this one as Facebook, and this one is YouTube. Whenever the message is coming, packets are demuxed and goes to a different receiving buffer, right? Then something like Facebook handles very small buffer. Something like YouTube should handle the big buffer because file size is bigger. Something like MLB Live handles in the middle. Okay, so packets demux, and this receiving queue handles end-to-end buffer. Meaning you should only receive as much as you can digest. If it is overflooded, then your video should be digested. Then you can continue to receive. So David says that send packets of the multiple process at the same time, or does it done by the slicing? So let's say I am YouTube handler. The multiple queue, I'm maintaining multiple queue, multiple messages coming. Then your UDP transport layer making one linear line. Then deliver to a network. So it's one pipeline. It's not multiple pipeline. It's one pipeline.
So is it using queue? Or is it?
This is queue. And so your process handles a queue. And UDP matters to the lower layer, right? So you make one pipeline to a lower layer, then handles this. So queues are existing on the higher layer, but in the lower layer, there's a pipeline. You're just passing through, digest or non-digest.
I see.
Okay.
Got it.
Thank you. So example of the UDP, oh, I'm watching a YouTube process, and the process, if you have YouTube request, then goes to and by a MUX, goes outside the internet world. If it comes back, okay, hey, here's a YouTube response, your video chunk. Where should I go to? Oh, come into this way. This is your YouTube watching CSE310, YouTube watching a BTS music video. So how they know? It is the same IP return and same port return because you're watching 2 YouTubes. And how they know it is different from watching YouTube from CSE310 and watching BTS music video. They do have different flag. Then how they handle? They handle by control block module. Then they handle the table. Okay. I request this process request this. This process requests this, the numbers. Then whenever it returns, even they are same IP, same port, they should have different process ID. Then they can handle. Okay. Then it is used as a flag. Okay. So control block modules are responsible for management of the control block table. So remember, by looking at table, even they are same IP and port, then they can distinguish because they do have the different process table. So this is called the control block table and request for port for a new starting process. If the port number is same, they using different queue number and update the control block table. In use is a free, meaning you can use it. In use and free meaning. Then there's process ID and port number and queue number. Okay, we have a multiple steps. Therefore, even I'm using different, even I'm using same application with the multiple the browser, then I still can service in a proper way. So Roshan said, does this mean multiple YouTube tabs on the Chrome use the same port and IP, but different flags? Different flags meaning different process, different queue number. Yes. So let me check it. Say I'm watching YouTube. Say I just opened the 4 YouTubes. I don't know what they mean, but let's say play everything. Make it to mute. 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 Play it. So whatever it is, make it mute. It is now I'm playing 4 YouTubes. Let's see my task manager. So I'm running a Chrome 14 of those. So 4 of them, among 14, 4 of them are YouTube player. Let's look at the details. So Chrome process ID is different, process ID is different, process ID is different. See? So you are running multiple Chrome with different process ID. Clear? Roshan? I hope so. So if I close it, oh, all processes killed. Okay. All right. Thanks for the question. David. What was the team? So we understand what it is, right? So team says. So could you think of the flag as like a header since we are using different samples? So difference between header and flag. So header and the control block. So headers are included every packet, right? Every packet has a header, but this one is your computer is maintaining table. So by looking at a process ID, that process was handled by this one. This process handled by that queue. That process handled by that queue. It's not exactly same, but it's somehow similar, but different concept. Flags are, so don't call it flag. Let's call the process ID and let's call the header. Header informations are included and encapsulated every packet. and they handled on the other side. But this process ID is meaningless on the other side. They don't really care. They do care about the IP and port. In the outside world, that process ID is meaningless, right? The other server on the other server only care about the IP and the port number. Whenever this packet is delivered to me, is back to me, then I'm looking at IP and port. If there is a multiple process at the same port, I should look at, okay, this was requested by that guy. This process requested by that guy. And how do you know that guy is that guy? That is table. Okay. That is the difference, because after I'm sending request, then I'm expecting something. Oh, I'm expecting something. If the coming to me, so I'm expecting this. Oh, you are expecting this. Then I can give it to him. Okay. Then it's slightly different, but it's very similar concept. Okay. So input module. So receive the UDP packets from the IP layer coming from lower to top, and look up the control table and the map port. If a queue exists, push packet to the corresponding queue. Exactly what I'm saying is, if not, allocate a new process. If nobody expecting that, I'm making a new queue and handle that. Then the process just realized, that's what I asked. Then they can start to digest from that queue. So output module, receive data from application layer and create the UDP packet and send it. And what's the advantage of UDP? So UDP is control over what data is sent and when, as soon as application process writes into socket. It doesn't need to have connection establishment. It doesn't need to care about the other's status. How's the receiving buffer status? They don't care, but they just send it as soon as they have messages. Okay, and therefore there's no delay for connection establishment, and there's no state. Since they don't have a connection establishment, UDP just send messages without contacting the host first. So they don't care about the receiving correspondent, but they just send it. And it pays off when the host is expecting messages anyway. So if the receiver can digest that I'm sending it, that is fine. If not, they will decline. Then I have to do a different procedure. Okay, if both of them are agree, okay, I'm expecting this, I'm sending this, then UDP is better. But if you run in the concept of the network meaning everybody connected network, it is very hard to make connection. Okay, so therefore, if you don't, then we are using TCP. If you know your receiver, then we can use UDP.
Professor, I have a question.
Sure.
So UDP doesn't have a handshake method, like any concept, like, right?
Yeah.
Then how would it know whether it's connected or not? Like the client and server is connected.
So we have a layer concept. That layer only responsible for that layer. UDP doesn't have, but in the process of the whole 7 layer, there is a different layer handles the establishment of the connection. Okay, something like if I already make a connection between A and B, then I don't need to worry about it. But the TCP, even I have a connection between A and B, then I should also connect a new establishment in that layer. In the process of packet delivery, there is something, but that layer, transport layer, doesn't handle. That's the difference.
Okay.
Okay.
Does it also have a mechanism if packets are lost in the way? Like
in the way, so UDP doesn't care, but the different layer should handle.
Oh, okay, I see.
Okay. Therefore, the best design of the system is as simplest as possible. So UDP is a design for simplicity. Okay. And therefore, it has a very small header. And it's only 8 byte. If you compare to the TCP, there is more than 128 byte as fraction of the TCP header. Okay. And they don't care about receiving buffer. They don't care about sequence numbers or anything. Therefore, it is easy to handle many active clients at once. The servers can handle multiple requests. What's the disadvantage of UDP? So they are doing best effort. Best effort meaning if I do my best, but if it failed, it's failed. Therefore, there is no guarantee of the delivery messages and no order delivery. And there's no congestion control. Of course, there is no flow control. No adaptation to the congestion of the network. So I don't care about the receiving buffer. And it also suppresses the TCP flow because UDP is just lousy. It's just sending it. The TCP cares that, oh, how are you? How's your receiving buffer? Can I send this? Okay, make a connection. Can I send it a little bigger? Okay, oh, you are not digesting, then I can shrink it a little. They do something. Okay, there are some guys who care so much about end-to-end, but I'm just sending it. Then what happened? Then I will overwhelm the TCPs. Therefore, UDP flow suppresses TCP flow. So in case of a congestion, TCP flow will back off while UDP stays on the same rate. Well, I don't care, I do my best. I don't care about you, but I do. But TCP on the other side, oh, how are you? How's your receiving buffer? Can I send this? Okay, how was it last time? Can I send it a little bigger? Oh, it wasn't bad. Then wasn't good. Then can I send it a little smaller? That's a TCP. Then UDP just like it keeps sending it. Then this is called the UDP flooding attack. So if I create more and more UDP, the TCP will naturally die, right? And this is one type of the attacking mechanism. So application of the utilizing UDP. So now I'm different concept, UDP and TCP. It is more appropriate for the multimedia live streaming. So retransmission or corrupted packets is not worthy. I don't need to transmit back. I'm watching MLB live, something gone is gone. I don't care. So by the time the packet is retransmitted, it is too late. Something like telephone call, video conferencing, and the gaming or the live streaming. And certain loss is acceptable since voice and pictures and that's still discernible. If you still even you lost some fraction of the voice, you're fine. I can understand that. Even there is some lagging. Okay. And UDP is a simple query protocol like a DNS, and delay for the connection establishment is too large. I can use it. So queries are small, and UDP has a small overhead, and easy to application retransmitted if needed, and usually may fit within a UDP packet. No order of danger. Okay, if it is satisfied, I can use a UDP. Okay, so now we back to the TCP. So TCP is a transmission control protocol. TCP, unlike the UDP, it is connection oriented. Connection oriented meaning explicitly set up and tear down of TCP session. After guarantee can I send you is so careful. Can I send you this much? Then they can send. And stream of a byte service, send the receiver a stream of bytes, not message. And it is reliable and it guarantees in order delivery. It checksum to detect the corrupted data, acknowledgement, and retransmission for reliable delivery, and sequence number to detect losses and data reordering. It does everything. And flow control meaning prevent overflow at the receiver. Congestion control meaning adapt to the network congestion. So it cares about greater good. It cares about everybody in the network. So everybody should be fair enough. Everybody share the decent level of the service. It's so careful, right? Unlike the UDP. So does TCP duplicate lower the layer services? This means TCP try to do everything what the other layers do, what the other layers already doing, right? Is it different duplicate? Do you think so? So let's pause in here. Let's think about this. This question says TCP duplicates lower layer services. Like UDP doesn't care and still working. Why? Because the other layer handles. But TCP handles everything. Is it doing someone else's job also? What do you think? So I'm gonna pick who was silent for a while. Yu Jungmin and Son Yeun. Any comment? What do you think? Jungmin and Yeun. So we understand this concept, right? We talked about UDP, and UDP doesn't care everything. Just be a greedy. And the other layers do their job. And the network's still working, and your data is transferred point to point. But TCP tries to do everything. Then is it duplicate the other ones, the other's job? Do you think so? No comment? Jungmin and Yeun?
I think it does.
Okay. Any support comment?
I'm not sure, but I think because it does not make any problem, so TCP can do all things that the other stop did.
All right. Thank you. So TCP, so the other does their own mechanism, and TCP is based on the sliding window. Concept of the sliding window, and the packets are coming in, handles and moving to different, moving to. This is time sensitive. It handles in sequence based on time. So it incorporates ACK and NACK. We know what the NACK means, negation of ACK. So I'm receiving, then that means, oh, here's the receipt. That is the ACK. NAG is, I didn't receive that packet. That is NAG, okay? In retransmission and timeout ordering, we understand what the timeout. I was expecting receiving for a while, that it didn't receive. So I called the timeout. I was expecting your response for that time, it didn't receive. Ordering means, I received 1357, 246 is missing. So you give me a 725212, whatever the order doesn't proper. So I handles, the TCP handle. Retransmission, that is wrong, please send me again. So how that TCP's job is different to the other layers. So TCP runs over the route rather than a single physical link. So needs to establish connection and negotiate parameter and sliding window size, okay? So the other network cares about point to point, but TCP cares about the network view, so end to end, and adapts to the heterogeneous condition. If something is different, so it adapts to. So round trip time varies with the connected host, time of day, and it is unpredictable. And TCP adapts to it. And flow control on a computer with the different resources. And reorder and retransmit packet end to end. And even the packets are in order, one physical link, this does not guarantee end to end ordering. So if the different layer did things, but actual service may not guarantee those. So TCP handles those. And they provide the congestion control. Congestion control is a network view. No immediate feedback from the link, no knowledge of the condition along the way. Congestion control based on the feedback. If there's something received, I can guess so many things, okay? It does, but it does the same function that the other layers do, but it is doing a different way. It is designed for the user to user, service to service. We call it end to end. So they are all doing different thing, but doing maybe the same concept, but different way. The TCP doing a thing which is designed for end-to-end. What's the actual service on me? Okay, so that's the difference. The TCP byte service, TCP buffer make a segment into bytes. Okay, previously it was a packet, now it is a segment. So in general, there's a TCP is a full duplex. We understand what is a full duplex. Half duplex meaning while I'm talking, I cannot speak. While I'm receiving, I cannot speak. While I'm talking, I cannot receive. That's the half duplex. Full duplex meaning while I'm talking, I can receive. While I'm speaking, I can receive. While I'm receiving, I can talk, right? So go to the point. So David says, what is the point-to-point then? So point-to-point is a TCP's concept and UDP's concept. So there is end-to-end. End-to-end. What else? The computer host-to-host. There's network-to-network. So in the network view, point-to-point, host-to-host, network is a common mechanism, a common terminology. Point-to-point meaning my YouTube browser, my YouTube server, whatever in the middle, I don't know. What I do care is about my browser. Is it showing my YouTube? Is it showing my YouTube? That point to the server. In the middle, I don't really care. But I want to know what is really service level. Okay, that is close to end-to-end concept. Host-to-host meaning it is digested. It is in my queue, but it's not playing well. Meaning it reached my server. It reached my computer. It's in my queue. Okay, network to network it's in my network. I can see my network is holding. Okay, that is in the middle. But what I do care is about end-to-end, point-to-point. Okay, that's the concept.
It's the same thing.
Hmm?
So end-to-end and P2P is the same thing.
Oh, and end-to-end is not exactly the network technical term, but point-to-point is technical term. End-to-end is more like abstract meaning.
I see.
Point to point, that point to the other point. Then we can say, it provides end-to-end service, which means it's working properly. End-to-end. How do you see the end-to-end? If you look at end-to-end as a host-to-host, it's end-to-end as network. If you end-to-end your application to application. Okay. Then in the view of the technical term, it is properly said that P2P is your point-to-point. Okay, so the TCP is known as end-to-end connection and point-to-point connection. And UTP this as well. The transport layer handles end-to-end. In this end-to-end meaning your service to the other service. Okay, so I think it is not different. P2P and end-to-end. Okay, so TCP segment, TCP data. So adding my header, I'm handled to my lower, right? So IP header is no bigger than a maximum transmit unit, MTU. It's up to 1,500 byte. And TCP packet is IP packet with the TCP header is data inside. We know the encapsulation concept. And TCP header is typically 20 bytes long. And TCP segment does not exceed the MTU, MSS, maximum segment size. So up to the 1,460 consecutive bytes. Okay, so I'm sending standardized packet. So this is the TCP segment look like. If you're comparing to the UDP, it is more complex. It has source port and destination port. It should have sequence number you should have ACK, header length, and the flag, advertise window, urgent point, and checksum is the same. And based on your version and based on your condition, you may have options. Okay. This is simplify the TCP flow. We have to understand what is a flow and what is a flow. Is commonly, when we talk about flow, it is sender to receiver. Then what's the difference between flow and flow control and congestion? So these two we need to differentiate. Flow is a sender to receiver. Congestion is a network. Okay, congestion is happen because there is multiple guys, multiple entities sharing my network. Okay. Data sequence number flow toward the receiver. Oh, sequence number. Then I'm receiving. I'm acknowledge and advertise window. So ACK and window size flow opposite direction. I'm going to show you in following slide. Okay. So connection establishment. TCP has three-way handshake. Meaning, can I send you? I'm about to send. Can I? Then, okay, with the sequence number X, sure, you can. Meaning, sure, you can is ACK with a new ACK number, a sequence number. And here is a +1 on your request. Meaning, I'm responding to this messages. And here's my sequence number from me to you. So I have to handle two sequence number. Meaning, oh, I received your response. Thank you. And here is your acknowledgement +1, meaning I just received this message and replying to you. Okay, then do it again. So whenever I wanted to establish connection, what do? Can I send you? Can I send? I'm about to send you data. Can I send it to you? Synchronize it. Here's my messages sequence number. Oh, sure, you can send to me. I'm acknowledged. On the sync ID, I can acknowledge. And I'm responding to this message. Sync number +1. Sequence number +1. Okay. Then my message is sequence number. I'm sending new sequence number, which is my message sequence number. Okay. Thanks for acknowledgement. And here is your acknowledgement on your last messages. Okay. So they are maintaining two sequence number. Sequence number by client, sequence number by a server. Okay. Then we should reply in different way. Okay. So TCP connection is three-way handshake. Let's go back to the point. So header field in the segment. So it explains this header information. So read it through. So source port and source IP address, destination port, destination IP address. It defined in a TCP connection and sequence number of first byte in the segment, and it has different flag, which is 6 of them, 6 field, synchronize. Can I send it? Connection establishment and synchronize. And fin is, I just finished. I just want to terminate the connection and reset. Oh, let's reset something wrong. Push is notification of the running over the TCP, and urgent. This is more urgent. Ignore others and handle this one first. AG is, oh, I received the well. Okay. Okay, we talked about the three-way handshake. And client is sync packet. So client port, server port. Remember, this is source, destination. Client sync packet is clients talk to server, and client initial sequence number. Remember this, initial sequence number. Then telling me this is SYN, and telling 20 is length, header length. Header length, and all the other as it is sent to client to server. Then server is responding, server to client. Okay, this is source, destination. Source from server to a destination, and server's initial sequence number. Then we understand what is y. This is y. This is x plus 1. Okay, client's initial sequence number plus 1. Then this is synchronization. At the same time, it is an ACK message, and header length is 20. Oh, now we understand what does the packet look like, right? So this message is happened in this process. Okay, clear? Then client's ACK, one way, two way, third way. Okay, from source to destination. Now I'm only sending, this is ACK messages, and this y's plus 1 is a send. Okay. So this is TCP transmission transition diagram. So if I'm playing with it, where is? Okay, so I'm starting this point, listening. So this is ready status. In the ready status, I may send the sync. Okay, can I send it to you? Then my status is SYN message is sent. Then I'm waiting for, if I am successful, let's say if I'm failed, I may close it. If I'm not failed, either two, if I'm succeeded, it's two-way. If the SYN is ACT, then connection is established. If just the SYN is received, okay, SYN is received, from SYN is received, then ACK is received again, then connection is established. From the connection established, what do? I just keep transmitting my connection, then I may exchange all the information, then I may close it, or I may just finish it. Let's say I want to close it with the finished messages, then I may go to fin wait. So I want to close this connection, then I'm asking close. Then the other entity is agreed on it, okay? Then you are okay, okay, let's finish it. Okay, you are okay, okay, time wait, meaning if it is there's no NAC messages, if there is no error messages, and wait for a while, then I'm close it. All my TCP connection is done. Okay, so in the middle, I can do all this thing. So this is how I draw a transition diagram on a TCP. It is more complex than a UDP. So whenever we design the system, we always draw this kind of a transition diagram. Okay, so I understand I understand that you could use this kind of the diagram before. So this is a little more complex than you used to do it. Then whenever you write the program, you can also make your code transition diagram. There is an app for the diagram flow to chart. In the Visual Studio, it supports the your program diagram. So Visual Studio supports this, and which function goes to the which function. So all the Python code is supporting this.
Professor, what is the difference between the SYN/SYN plus ACK and SYN plus ACK plus /ACK? it's the arrow pointing out from SYN_sent.
Since sent, I have this path and this path. Is it what you're saying?
Yep. What are the difference?
Okay, so to make a connection established, what do I need? I need the 3 times of the handshake. I do SYN, then SYN-ACK or SYN-ACK-ACK. ACK meaning SYN, SYN-ACK, and ACK. Okay, so this is this guy, and this is this guy. So SYN-ACK-ACK is after 3 connection is done, and SYN received is this status 2 times. Then you need to have 1 more ACK, then you can connect. You can establish connection.
Okay. All right.
So it's just the diagram representation, nothing complex. Okay. So you know how so if you write the program in Visual Studio, So let me share. So whenever you write the program in the Visual Studio, they can plot this kind of the diagram. So which function goes to which function, function goes to which function. Okay. So in a database, they do also this kind of thing by clicking legend in a Visual Studio. And this is very common process. Okay. They draw automatically. And Python also supports this. All right. So tearing down the connection, let's say TCP connection, and fin and reset, and finish and close. So let's say I am client, I am a server. Hey, I want to connect to you. Sure, you can. Okay, thank you. Then I can keep sending my messages. Okay, everything is act. Okay, all my connection is done. Let's finish my connection. Okay, I receive your connection to finish and receive the well. Let's send then actual send the finish, then act. And this is the end of the TCP connection. Let me repeat. So it could be client to server, server to client. Let's say point A, point B want to have a TCP connection. What do I do? Can I send it to you by sending a SYN? Oh, your message to a request is well replied. Okay. Okay. Thank you for your reply. I'm about to send. Then I'm send messages. And oh, I received the well, send messages, I received the well, send messages, receive the well. Okay, that was my end of messages. And now I want to finish. Relate the connection established between A and B. Why do I need to finish? If it's not finished, it is allocated to my queue. I have to open my queue. Therefore, it takes up my resources. As long as that is not necessary, I should keep closing, right? Then I can maintain my receiving queue and tight is enough and light is enough. Then I have to send, oh, I want to finish the connection between you and me. Because what I want to do is all done, okay? Oh, your request to act is well established. Your request to finish the establishment is well acknowledged. Then here's my fin messages. Thank you for your connection. Then this is actual end. There's no more connection. Okay, so this is the how TCP works, sequence by sequence. Okay, this is what I prepared today. Any question about TCP? So I'm going to talk about more, one more lectures on the TCP. Then we're going to move on to a different subject. Any question? Yep. Okay. All right. Some of you who applied the AI job in the Gangnam, congratulations, you are all hired. Okay. So if the new job is coming in, then I'll post it to you and circulate it among you guys, and I will make sure you guys have the internship opportunity. So for the non-Korean, I'm keep looking for the jobs where you can take for interns. Interns is great. Then you can have real hands-on experience in the field. Then you can learn more. Okay, please understand, I'm keep looking for the job where the non-Koreans can take it. Well, by the visa issue, it was too tough to find the job